Bismillahirrahmanirrahim. Assalamualaikum dan selamat sejahtera. Today I will explain one of the important topic in memory management, which is swapping. Okay. We look into the content. So the first content here is why swapping is needed. Why swapping is needed? Swapping is needed because of this problem. The problem is input-output is so slow compared with CPU. Even in multi-programming system, CPU can be idle most of the time. So you have CPU here, okay, and then the CPU can be idle because all the processors in the main memory, so this is the main memory, and all the processors here has been blocked because they are waiting for input-output operation. And input-output operation is very slow compared to CPU. So CPU here cannot execute any of this process. Okay, the process must be in ready state in order for the CPU to execute any of this process. Okay, what is the solution that we can use? One of the solution is to add more memory. We can add more memory, but it's quite expensive, and also it will let the developer tend to develop a bigger program because the developer see that the main memory is larger now. Okay, so one of the solution that can be applied by the memory management is by using the technique swapping. Okay, now I will explain what is swapping. Before I explain that, we look at this simple job scheduling. Okay, usually all the processors will be stored in this storage. So all the processors will be here. Okay, so the process which is in the ready state will be swapped into the main memory. Okay, so let's say there is a space here, there is available space here. So what happened here is that the processes in this storage, let's say there is a ready process here, so the process here will be swapped into the main memory. Okay, so this has been blocked, this process has been blocked, but this one is ready to be executed. So the memory can execute, so the CPU can execute this process. So the process will be executed by the CPU. Okay, the CPU will execute this process, and then the completed jobs will be swapped out from the main memory. But the issue here is if all the processes here are not ready. Okay, are not ready. All of them are in a block state. So how we want to proceed? Okay, the CPU cannot execute any of this process because the CPU need the process to be in the ready state. So one of the solution is to use technique swapping. Okay, so what happened in swapping? We can swap out the block process. So where? So we can swap out this block process into a location in a disk storage. Okay, so if you look in a disk storage, in the swapping, there will be two queue. The first queue is for the intermediate queue. The second queue is for the long-term queue. So the block process from the main memory can be swapped out into the intermediate queue. Okay, so now your memory have one available space here. So next we can swap in ready process or new process. So if there is a ready process or new process from the long-term queue or from the intermediate queue, we can swap in this process. So take this process and swap into the available space here. So now, therefore, the CPU will not idle for long. So the CPU can execute this process. The concept here is that swap in, swap out. Okay, so let's say your memory is full, your CPU is idle now, so you just take the one of the block process, put the block process into your disk storage in the intermediate queue, and then take the process which is already in this disk storage. There must be process which are ready. Okay, take that process and put into the main memory, so the CPU now can execute that process. So this is the technique of swapping. Okay, let's say you have another issue. How if a user wants to run a program bigger than the size of main memory? Okay, you want to run a big program here. Let's say your lecturer asks you to run that program, and you have you don't have enough money to buy a bigger RAM. So what you can do is to use virtual memory, and paging is one of the important concepts in virtual memory. So in the next video, I will explain what is paging, inshallah. And this is the end of this video. Thank you.